Hey, Wade.
Hey Carly, now let's dive into coding some of this random number generation here in Python. So we have a few practice problems to go through. This says Python provides us with the ability to compute a random number. Let's first have the computer simulate rolling a fair six-sided die. So to do that, you know that we simply have to import random. And then once we've imported random, we can say random.randint 1, 6, specifying the min value and the max value. So Carly, if you run this, what do you get?
Ooh, I got an error. I spelled randint wrong.
Yeah, so the tricky thing about Python is you have to get every spelling and capitalization right.
Exactly.
But if you get an error, it's just a matter of kind of looking at it and seeing what happened.
I knew right away that I had spelled it wrong, but I got a 2.
Awesome. And let's run this a couple times to make sure it's truly random, that you're not just always getting a 2, that the computer's actually rolling a die.
And I got a 5 on the second one, a 4 on the third one.
Awesome.
5.
Awesome. So it truly is simulating rolling a die, and the result it gets, a number between 1 and 6, is basically the same as a face on the die. So here we can go into some puzzles. So what if we wanted to use Python to simulate flipping a coin? So here we can decide on what we want this coin to be. And I'm going to say we're going to have the numbers 0 and 1 because I like starting counting from 0.
Okay.
So which one do you want 0 to be? Do you want it to be heads or tails?
I feel like 0 is usually tails.
Sure. So I'm going to make a comment by using a hashtag and say 0 is tails and 1 is heads, just so I know what to expect when I see the result. And now I can simply say random.randint, and we know the minimum value is 0 and the maximum value is 1. So we do 0, 1. And by doing 0, 1, we specify the range we want it, and we always have to have minimum value first, the maximum value second. And then doing this, I expect this to simulate flipping a die.
A coin?
Or a coin. And basically I should see either 0 or 1s randomly. And what do you see, Carly?
I see a 1 for my first flip, 0 for my second flip, 1 for my third, and 0 for my fourth.
Awesome. So we're going back and forth and we're randomly generating a 0 or 1 depending on the randomization that happens at the time. So it's just like flipping this coin. Second puzzle, use Python to simulate drawing a random card from a deck of 52 cards. So we're going to explore a lot of different ways to do this, but I think the simplest and easiest way is to think about all 50 of these 2 cards as uniquely numbered cards. So I could think of maybe like the 2 of clubs as the first card, and then you might think about the 3 of clubs as the second card, and you can give a unique number to every single one of these cards, and that's one way to think about randomizing these cards.
Yes.
So there's 52 of these cards. So if we pick a number between 1 and 52, we've uniquely identified every single one of these cards. So to randomly draw a card with a number, we can simply say random.randint 1, 52, where again, 1 is the minimum value I'm choosing and 52 is the maximum value I'm choosing. And this will simulate drawing a card by using the range 1 to 52. So because this is quite a big range, I'm going to expect that it's going to be very, very unlikely for us to see the same number twice. So the first time you run it, what'd you get?
I got a 3.
3, and then
15.
15.
16.
Oh, 2 cards very close to each other.
51.
So we're randomly simulating this. And because we always have 52 cards, this is simulating it by replacing the card every single time.
Drawing with replacement, exactly. So this basically simulates drawing a card out of the deck, and when I draw again, drawing with replacement.
Exactly. So puzzle 3, now this gets a little tricky, and I'm going to need your help to think about how we want to arrange these numbers.
Sounds good.
So use Python to simulate spinning a roulette wheel. And a roulette wheel is a wheel that contains the numbers 0, 00, and the values 1 through 32. And it says, don't worry about the colors here.
Okay.
So we just want to think about the numbers. So I think the numbers 0 through 32 make a lot of sense, that those are natural numbers. They fall in a range. But double zero.
Ooh, could we just say that 33 is double zero?
We could certainly say 33 is double zero. And this is actually an interesting design choice. And this is where I might make a different choice than Carly would make. So I feel like 33 seems like a legitimate number almost. So I actually feel like -1 may make more sense to me as an engineer, because -1 just seems like double zero. It's like,
oh, I didn't even think that we could do negative numbers, but you're right. Let's do that.
Okay, we'll go ahead and do negative numbers, but you could totally do 0 through 33. That totally works, and it's completely a design decision that you get to make as a programmer. So I'm going to choose that -1 is going to be my double zero. Then I have the zeros through 32. So here we'd simply say random.randint. Our min value here is now -1, and our max value is 32. So that's now 34 different numbers. So we have -1, 0, and then all of the numbers 1 through 32. So this simulates a roulette wheel. With 0, 0 as -1. So, Carly, spin that roulette wheel, and where does the ball land?
A 9.
A 9. Okay, a red 9. And what do we see next?
7.
7. And
let's do one more. 3.
so if you were betting today, you definitely want to be betting on red. Those are all red numbers. So, awesome. One thing I want to dive into is some of this became a little less natural to think about numbers and mapping things. So Python gives us a second way that we can make a choice about what random numbers we want to generate. So what we can use is we can use a second command in Python to allow Python to choose between many different options that we specify. So random.choice allows Python to choose a choice among many different options. So this one says, let's have Python roll a fair 6-sided die or any other things. And this particular problem says to generate a random word among green, blue, and red. So basically, it's as though we have a number of different dice. We might have a green dice, a red dice, and a blue die. So we have 3 different die. We might stick it in a bag, and we want to draw one of these dice. So I randomly drew a blue dice. So instead of mapping these to numbers, we can actually specify the 3 different words. So random.choice, and I'm going to put a square bracket to indicate I'm giving Python a list. Then I'm going to specify blue, red, and green inside of my list. Close off the square brackets, a comma in between each item in my list, close the parentheses. And Carly, if we do random.choice, what do we get?
I got green.
You got green. So the first time Carly drew out of a bag of 3 die, she got the green die. What about the second draw?
Red.
Then she got the red die. So it doesn't matter which order we put these in the list, because the list itself is going to just simply be randomly thrown together, and one of them is going to be pulled out by Python. It's going to choose exactly one from the list of items we have. So now we can dive into a few more puzzles and nerd out using both the random randint as well as the random choice. So for this first puzzle, it says to use Python to simulate flipping a coin that lands on heads or tails. So now we can think about the 2 coins, and we can think about the sides not as a number 0 or 1, but just side heads or side tails. So I'm going to go ahead and use random.choice to make this kind of an easier problem to understand what the computer's doing.
That sounds good.
So random.choice. And here are 2 choices. I'm going to have a parentheses, and then I'm going to have a square bracket to give myself a list of choices. And in quotes, I'm going to say heads, and then comma, tails, in quotes, in square brackets, in parentheses. So I have a list inside of my random choice function. And Carly, when you flip a coin, what did the computer give you?
I got tails on my first flip, and then I got tails on my second flip, tails on my third, tails on my fourth.
4 tails? Okay.
Oh my gosh.
This is like a 1 in 16 chance.
And then I just got heads.
Awesome. So 4 tails in a row, and finally heads is what the computer simulated. And we could have done this with a real coin.
Yeah.
And that's completely probable to get that it's
exactly.
A real coin might end up tails many, many times in a row.
I had a quick question, Wade. What if you wanted to simulate, could we use random.choice to do 000 through 32?
Definitely.
Okay.
Yeah, we can definitely specify a lot of different things inside of that list. But if you think about that list of 000 and 1 through 32, we'd have to specify all of those items in the list.
Oh, so you couldn't put 0 through 32?
No, you've got to specify every single item individually.
That seems like a pain. Using -1 probably would just be easier.
And we'll learn some tricks to allow us to do this with a few less lines of code. But
Got
right
it.
now, every single option you have, we'll just list out explicitly.
Got it. Okay.
So to fill out this description, this will randomly pick either heads or tails. All right, next we're gonna approach doing the same example we did just a few minutes ago with this deck of cards. And now instead of assigning every single number 1 through 32 or 1 through 52, now I can actually think about what these cards actually have on them. So here I'm going to go ahead and have us write 2 different cells and run 2 different cells to help us simulate just one event. Because every single card, it is made up of 2 different components. Every card has a rank, which is either the ace, the king, the queen, the jack, or it has a suit, which is your clubs, spades, hearts, diamonds.
Right.
So what we can do is we can have 2 different random options that we can run at the same time to specify both the rank and the suit for every single card. So the first cell, I'm going to have this be 2 separate cells. For the first cell, and I'm going to run both cells every time I want to randomize a card. So the first cell, I'm going to have us randomize a suit. So I'm going to do random.choice. And our options for suits are a club, a heart, a spade, and a diamond. And the exact order you list these inside of Python doesn't matter when you use random.choice because it's going to randomly choose them with equal probability. So if we run that, we get what our first suit is.
Diamond.
Diamond. And now we need to find out what the rank of the card is. So we can write a second random.choice and say random.choice. And we have an A, a K, a Q, a J. And because we already have some strings in this list, even though you're going to be writing numbers after this, we still need to put quotes around these numbers because everything in the list needs to be of the same type. So if we have some strings, they need to all be strings. If we have some numbers, they need to all be numbers.
Got it.
So when I write 10, even though normally I'd write 10 without quotes, because it's along with other strings, I'm going to go ahead and write 10
That
in
makes
quotes.
sense.
9, 8, 7, 6, 5, 4, 3, and 2. So now I've got a random.choice of both the suit and the rank. So if we run this choice, what does Python give us?
A 5. So the 5 of diamonds.
So our first card was the 5 of diamonds. And Carly, why don't you rerun both of those cells and see what our second card is?
Could I actually put them in the same cell?
You could put them in the same cell, but the reason I did separate cells is the Python will always print out what the last thing it did was.
So we'd miss the suit.
It would still actually do it. It would still actually generate it, but it won't print it out.
Good to know. So now we got, when I did it a second time, the Queen of Hearts, my favorite card.
Did you really get that? That's amazing.
I swear it did. Look.
So, completely random, second card Carly drew was her favorite card. So I actually like the, what if we want to do it in the same cell? So let's go ahead and assign these randomizations variables. So I'm going to call the suit, let's go up to the suit cell and say suit is equal to random.choice. So you're just going to begin in the line say suit is equal, and then say rank is equal to random.choice from the rank choice, and go ahead and stick both those statements in the same cell.
Perfect.
And when you do that and you run it, you should see that absolutely nothing is going to happen if you run it just as is.
Nothing happened.
So that is because Python internally said, hey, I've stored your suit and I've stored your rank. So now we just need to ask Python to print it out. So let's go ahead and say print, and then inside the parentheses, just say suit plus rank and close the parentheses. And if you run the cell now with the suit and the rank being randomized and then printing it out, what do we see?
Diamond 8.
Diamond 8, so the 8 of diamonds. And let's run it again to just make sure we're really doing something random.
Club A.
And the ace of clubs. So it may have made more sense to say rank plus suit. Normally people read like the ace of clubs, but this is something that you can choose, that you're in control of this and you understand how the suits and the cards are being randomized and how you're printing out the combination. So we have one last puzzle as we dive into this. So now one thing that we may want to do in simulation is having probabilities be unequal. So here, use Python to simulate picking a die from a bag of dice containing 3 black die, 2 red die, and 1 blue die. So I'm going to grab 3 black dice, and then I'm going to grab 2 red die, and I'm going to grab 1 blue die. So I've got this combination of dice right here. And if I have this in a bag, is it equally likely for me to draw each color?
No, because there were a different amount of each color.
So what's the most likely outcome?
It looks like the black. There's 3 black dice.
So to do this in Python, we can actually give black 3 different options inside of our list, which means it has 3 chances to choose the black option. So to go ahead and do this, I can do random.choice. And have my list contain black 3 times for the 3 black dice. So I'm just repeating the exact same word 3 times. Then red twice for the 2 red die. And finally, blue once for the 1 blue die. Close out my list, close out my parentheses, and this will randomly choose a die based on the frequency of dice in a bag. So if you run this, Carly, what do you get?
I got black on the first one.
Got black, and that's half of the time because 3 of the 6 options, Carly's going to get black. So if you run this a couple more times.
I get black again.
Second black.
Red.
Red, which is the second most likely outcome to occur.
Black again. Red. Red.
And there's only a 1/6 chance for Carly to ever get blue, so it's going to be pretty rare for it to ever get blue.
Black. Now I want to get a blue. Black. Red. Blue.
Oh, finally. So maybe 10 or 11 times, which is not that uncommon because there's only 1 blue die in that entire bag. So since we're replacing the dice every single time we draw it, it's going to be only a 1 in 6 chance of getting it. So there may be a long streak before you actually draw the blue die.
Exactly.
So this is just a bit of how we can use Python to begin to think about simulating real-world events. And we're going to start with just basic things like cards, coins, and dice. But we can add to the simulation and get increasingly complicated simulations to the point that this is actually the base logic of how you simulate launching rocket ships to the sky and beyond. Because all you have to do is think about every single real-world variable and having the computer help us out because it's really expensive to launch a rocket ship. So computer scientists simulate all the variables similar to simulating drawing a card, but simulating all the force of gravity and all of the different physical interactions. So this basis of simulation is key to almost everything else we're going to be doing in this series.
That's so awesome.
So that's simulation, and that's the very basis of simulation. So keep nerding out, and I'll see you in the next one.